Next up, we have analyzing rational functions of the form y equals a over x minus h plus k. So you'll remember from before we had looked at an example of this previously, and I said we'll worry about it later. Well, here's the later that we're worrying about it. So to obtain the graph of a rational function of the form y equals a over x minus h plus k, from the graph of y equals 1 over x, we apply vertical stretch by a factor of a, followed by translations of h units horizontally and k units vertically. You'll notice that we kind of skip over the horizontal stretch, but if you remember back from radical functions, a horizontal stretch and a vertical stretch could kind of be the same thing. The same thing's going on right here. When we look at a rational function, we only look at it in terms of the vertical stretch. So we have that a represents the vertical stretch factor, h represents the horizontal translation, rather there's a vertical asymptote at x equals h, and k represents the vertical translation. There's what we call a horizontal asymptote at y equals k. When we're transforming these graphs, what we're going to most likely be doing is just looking at my vertical and my horizontal asymptote, moving those, and then after we've moved those, we could fill the rest of the graph in, as you guys will see in a bit. So, some equations of rational functions can be manipulated algebraically into the form y equals a over x minus h plus k by creating a common factor in the numerator and in the denominator. Rather, write y equals 3x minus 2 over x minus 1 in the form of y equals a over x minus h plus k. Though the fractional form where we have, say, f at x over g at x is the common way that you guys will see rational functions, and that is considered to be the more simplified version of it, it doesn't tell us what the horizontal and vertical translations were. So to find the horizontal and the vertical translations, what we're going to do is we're going to use some mathematics to take one form and turn it into the other. Starting off, I have y equals 3x minus 2 all over x minus 1. I want to get it into the form y equals a x minus h and then have that plus k right there. You'll notice that in my top right here, there's no x value. So what I need to find a way to do is cancel that x value off the top. But that x value is attached to a 3. So to cancel it off right here, I need to find a way to get that x minus 1 factor. And since there's a 3 attached to the x, I'm going to pull a little bit of fun mathematics right here. We're going to go y equals 3x minus 3. Now, since I put the minus 3 in right there, what do I have to do? I have to add 3. And then from before, I had the minus 2, and this is all over the x minus 1. Well, what does this really do for me? In my next step, if I now go y equals, and I factor the 3 out of the first two terms, what I end up with is that x minus 1 factor that I've been looking for. From there, I have plus 3 minus 2, so plus 3 minus 2 will leave me with plus 1, and then this is all over the x minus 1. Now, if I separate my fraction right here, I'm going to get 3x minus 1 all over x minus 1 plus 1 all over x minus 1. That gets me the cancellation of the x minus 1 factor right there. And then just with a quick rearrangement, I now get 1 all over x minus 1 all plus 3. So that's the quick way that we're going to be able to manipulate between these two forms. Now, if I wanted to go backwards on this, all that I do is I take this value right here and I put it over the same denominator right there. So let's look at this. We're just going to go with a complete reverse right here. We're going to practice the algebra to show that it still works. And I go y equals 1 over x minus 1 plus 3. And I'm going to multiply the top and the bottom by x minus 1 there. This then will give us y equals 1 all over x minus 1 plus 3x minus 1 all over x minus 1. Now that I have the common denominator, I can simply put the tops together, and we get y equals 3x minus 1 plus 1 all over x minus 1. Expanding this out, I get y equals 3x minus 3 plus 1 all over x minus 1, which will give me y equals 3x minus 2 all over x minus 1. And if we look, we will see that was the exact statement or function that I started with. So we can do this in the forward order, or we can do this in the reverse order. Moving on, right now what I'd recommend is that you guys just quickly pause this and give this question a try to see if you can figure it out for yourselves. For me, what we're going to do is we're just going to move on because you guys can press pause, and I'm trying to keep these videos around the 8-minute mark per. So write y equals 3x plus 6 all over x minus 4 in the form y equals a all over x minus h plus k. So starting off, I write out my original function, y equals 3x plus 6 all over x minus 4. Again, what am I trying to match? I'm trying to match that x minus 4 right there. Since I'm trying to match that x minus 4, I need to minus something from the top where I'm going to be able to get this 3x to the x minus 4. And if we think about it, well, 3 times 4, negative 4, is negative 12. So we're going to go 3x minus 12 plus 6. And then again, this is all over the x minus 4. From there, I again bracket off my first two terms, and I factor the 3 out of the first two terms. So I get 3 bracket x minus 4 plus 12 plus 6, which is plus 18, and that's all going to be over the x minus 4. Again, I use the fact that my fractions are separable, so we get 3 bracket x minus 4 all over x minus 4 plus 18 all over x minus 4. That gives me the cancellation that I'm looking for, leaving me with y equals 3 plus 18 all over x minus 4, or just rearranging it, I get y equals 18 all over x minus 4 plus 3. Now, we're not going to go backwards on this one. I just went backwards to show you guys that it is possible to go backwards. And instead what we're going to do is we're just going to state what all the transformations are that are going on here. So looking at my a value is 18, so that means that I get that vertical stretch by a factor of 18. I see that I have the x minus 4, so that gives me the NPV that x does not equal 4. And that also tells me that I have a vertical translation of 4 units to the right. Or rather, my vertical asymptote has moved 4 units to the right. Then looking at that plus 3, that tells me, oops, I just noticed that's not a vertical translation. That is a horizontal translation. I apologize about that one, guys. Then I look at that x does not equal 4, or I look at that plus 3, and that one's going to tell me that I have a vertical translation of 3 units upwards. Or rather, my horizontal asymptote has shifted 3 units upwards. Now, another way that we could do this is using long division and writing the division statement in the form p at x over dx equals q at x quotient of x plus remainder of x all over the divisor of x. We're not going to do it that way though, because it does tend to be a bit lengthier and it's a bit easier to do it in the algebraic form. So that's another lesson for you guys. I hope you have a good one.